Hi, my name is Min. My project is vocabulary app, and this is the presentation for my app. So let's start with the introduction. There are five requirements for my app. The first one is that it allows users to add vocabulary to the library, and they have to be persistent, meaning that when user turn off the app and turn it back on, they still see the vocabulary. User can edit the vocabulary or remove it completely. Um, when you should add a vocabulary, it will automatically detect the language and then find the definition. So this means that the user only need to enter the vocabulary but nothing else. User can also view the definition of the vocabulary on the dictionary website directly in the app. And the app also allows users to upload image and then extract the vocabulary from the image. And then they can select which one to add to the library. So here's the technical information and the technology I use for this app. So I use Retrieve Xcode A. So this is not the latest version. And I use core data to store the vocabulary locally on the device. And the architecture is MVC. So we have three different layers, model, view, and controller to make the app more scalable in terms of coding. The prototyping tool I use is the marvelapp.com, and the UML diagram designing tool is draw.io. And more importantly, two API are required for this app: Google Translate API and Google Cloud Vision API. The Google Translate API will help us to detect the language and get the short definition of the vocabulary. And the Google Cloud Vision API can detect the text from the image and then extract them. And for web dictionary, we use Colin Dictionary, which support Germany, French, Spanish, and English. Now let's take a look on the UML class diagram. At the center, there is a vocabulary data store. This is a model where it fetch and delete the data from core data. As we can see, it has other method for the controller to interact with. This is my mistake to have a reference of the table view inside this model because the model should not interact with the view directly. So this model interacts with the Google Translate API to fetch the definition. When the result comes back, it will notify the table view controller, but and to update the table view accordingly. But here I make it that it will load the table view directly. So this is not a good practice. Vocabulary data store have multiple vocabulary entity, and each entity have for attribute universal ID to identify each vocabulary, the vocabulary itself, the language of the vocabulary, and then the last one is the definition of the vocabulary in English. The second model we have is the text result. This model does not interact with the core data. It just uses the Google Cloud Vision API to fetch the text result and store them in an array. So when the API can't return the data, it should notify the text result view controller. But again, I make it this reload the table view directly. So we shouldn't do something like this. At the top left corner, we have vocabulary view controller. This controller inherits UI table view delegate and the UI table view data source. So this controller controls how the vocabulary will be displayed in the table by defining on the delegate and the data source method. It's also have the vocabulary data stored to fetch the vocabulary from core data. The next one is the add vocabulary view controller. This one have text view status button and also the data store to save the vocabulary into core data. Edit vocabulary view controller have the similar thing, text view, save button, but also a universal edit to identify which vocabulary we're currently editing. The detail view controller will display the full detail of the vocabulary and also have the universal ID to identify which vocabulary we are currently viewing. On the other hand, the web view controller needs the vocabulary itself and the language of the vocabulary to we need the vocabulary and the language to determine the URL for the colon dictionary website and to load the website into UI web view. For the text recognition view controller, we have UI image picker controller. This controller will let user pick a photo from the library or take photo from the camera. Calling use photo will actually display the photo album, allow user to pick photos. Calling tag photo will actually open the camera, allow user to take photo. So the last one is the text result view controller. This controller will control how to display the abstracted text from the image in the table view. The cell for this table is actually customized into the customized class is a result table view shell. Each cell will have vocabulary and the add buttons. When user tap on the add button, it will add the vocabulary into the library. Now we look at the more abstract version of the MVC diagram. So let's focus on the model first. As we know, the model interacts with the core data and also the API to get the data from third parties. Here we have to use Google Translate API and the Google Cloud Vision API. The model provides the logic for our application, so it acts like the brain of our system. The model interacts with the controller through notification. Whenever the data inside the model changes, it notifies the controllers so that the controller knows to react accordingly. We should not have any direct relationship between view and model like I did in the UML diagram. The controller, on the other hand, reacts to user interaction. It converts user action into model update, such as add, edit, or delete vocabulary. It can also get data from model and display in the view. The controller can also handle on the segue or navigation logics. For example, we can send data to different controllers through the repair for segue method. The controller can also select and control how the view component display through the delegate and data source. The view is what users see and interact with. The view send the user action to controller, such as tapping on the add button so that the controller know and react accordingly. So now we are looking at the demo for the app. The first one is the main screen. It displays on the added vocabulary in the table. In Israel, we can see the language, the vocabulary, and also the definition. And you can see we can swipe left to delete the vocabulary. When user tap on the add vocabulary icon, this will navigate to the screen, and then user can enter the vocabulary, and the app will automatically detect the language and fetch the definition. If user enter the vocabulary incorrectly, they can tap on the edit button. It will navigate to the edit vocabulary screen. Then user can modify it. Again, user does not have to enter the definition of language. If the definition are too long, like in this case, user can tap on the detail buttons. It will navigate to the detail screen, allow user to view the full definition. Whenever user want to view the definition on the website, they can tap on view on colon dictionary. It will navigate to the web view and will load the web directly in the app, so user can view the better and longer definition. However, when user tap on the vocabulary that does not have the language is not supported, then the alert will display and saying that the language is not supported. It's currently support French, Germany, Spanish, and English. So let's go back to the main screen. And when you tap on the text recognition icon, it will navigate to the text recognition screen. In this screen, user can choose to to upload a photo from library or to tag the photo. When user pick a photo, it will upload it and then display the result. This is an example image I use. So after I upload it, it will display the result in the table. If we want to add the vocabulary to library, we can tap on add to library. And if we upload an image that does not contain any vocabulary, it will display no vocabulary file. In this part, I will evaluate my projects for completeness and correctness. For completeness, I satisfy on the requirement that I described on the very first line. The problem is that I use Witchery, so we cannot install the app on the device that have the latest version of iOS, which is iOS 11. So I have to migrate to 3.4 if I want to launch in App Store. For correctness on functionality, work as expected. Currently, there's no bug file on the iPhone, but we might find some bug in the future if we have unit testing or integration testing. Another problem is that the user interface looks very bad on iPad, especially the table view does not scale horizontally. The actual lesson I learned from making this app. The first one is MVC. It is a suitable architecture for developing apps because with separate components by responsibility, it will make the app more scalable. And also, this is not a good idea to let the view communicate with the model directly. The second lesson I learned is that core data is not portable. What I mean is that we cannot make a desktop app or web app that use the same data because core data is local to the device. So the recommendation is to use Firebase. In conclusion, the app is complete and usable on iPhone with iOS 10. I haven't tested on iOS 9 and below yet. And before writing the implementation, it is a good idea to make a prototype and then design the class diagram. This will help us to understand the complexity of the projects. And MVC architecture can be used to develop scalable apps. And finally, we should store the data in the cloud, such as Firebase, so that the data can be accessed anywhere. This is what we need to do for the concept of Internet of Things. Thank you for listening.